Hello guys, welcome back to my YouTube channel. I'm Harshan from Department of Electronics and Communication. Today we are going to discuss about numericals on Thevenin's and superposition theorem. The first question is, for the network shown in the below, apply superposition theorem and find the current I. As you can see in this network, we need to find the I in this network. Response across the any branch is equal to response of the individual algebraic sum of the individual components. For that we can write the equation as I is equal to Ia plus Ib. Ia means we will neglect the current source, and to find Ib we will neglect the voltage source. And now we to find Ia, open the 5 ampere current source and retain the voltage source. The resulting network as shown in the figure. We return the network by neglecting the 5 ampere current which is in this network given in the question, and resulting circuit will be this one. We neglected the 5 ampere current here. After getting a simplified network, you can see in this network the 8 ohm and the J10 which are in the series here, so we can add them. That is 8 plus J10 here we written here, and 4 ohm and minus J2 which are in also in series, so we added here 4 minus J2. And now this 8 plus J10 and minus J2 which are in parallel, so we can write 8 plus J10 into minus J2 divided by 8 plus J8. So we can get the impedance from this network. That is, by using the calci, select the polar mode and convert this polar form into the rectangular form, and you will get this answer. After getting the answer, we know the value of voltage here in the circuit. After getting the Z, now we need a I. We know that V is equal to IR. In this case, V is equal to IZ. So we can write V is equal to I is equal to V by Z. V is J20 divided by Z is we calculated here, and by converting into the rectangle form, and we will get the answer also here. In the previous slide we completed calculating the value of Ia. Now this is second case, we are calculating Ib. Next, short the voltage source and retain the current source. The resulting network is as shown in the figure. This is where we neglected the voltage source. As you see here, one voltage source is present, we neglected that, and we considered the current source here. And here we can directly say that the I3 is equal to the, here I3 is equal to the 5 ampere. Okay, and by applying a KVL to the mesh 1 and 2, this mesh and this mesh, we get the equations, two equations as shown here. By simplifying, we get the simplified equations. After this, we have the formula to calculate this imaginary containing equations. By substituting that formula, we get Ib, and taking the determinant, substituting the values here, 8 plus J8 and J50 and J2 minus J10, and in the denominator 8 plus J8, J2 and J2, and 4 minus J4. After simplifying this, we will get the answer in this form. And we calculated the Ia and Ib. As superposition says that the current of at any branch, the response at the any branch is equal to the response of the individual sum of the individual sources. It means here why we taken the negative means here Ib direction is at the downwards, but the question they given the I direction is upwards, so it is in the reverse direction because we written in the here a negative sign. We get the answer by subtracting. Going to the second problem now. The Wheatstone bridge in circuit shown in the figure is balanced when R2 is equal to 1200 ohm. If the galvanometer has the resistance 30 ohm, how much current will be detected by when the bridge is unbalanced? R2 to 1204 ohm means Wheatstone bridge is balanced now when the R2 is equal to the 1200 ohm. We are replacing this 1200 ohm to 1204 ohm, and we are calculating the how much current will be detected. Now as you can see, I said we are replacing R2 as 2200 to 1204 ohm. Now the Wheatstone bridge is unbalanced. Now we need to calculate the resistance. We need to calculate the current. The resistance of the galvanometer is 30 ohm. We need to uh, calculate the current across this galvanometer. Okay. Now we are applying the Thevenin's theorem to this problem to find the VTH. We find VA. VA means here VA. V means IR. I means this is 600 ohm resistor, and I1 value is 120 by 900 plus 600. We get as a 48, and across VB here I2 we can calculate as V by R, that is V is the same voltage flowing here 120, and the resistance is 1204 plus 800. We get I2, and substitute here V is equal to IR. I is 800 and R is 800 and I is this value we calculated here, and 120 by 1004 plus 800. After calculating we get 47.904 volt. After this we need to find VAB, so that we will subtract that VA minus VB. Okay, after that VA, after subtracting that, we get answer as VAB is equal to 0.096 volt. We found a value of VTH, and we need to find the RTH now. To find RTH, voltage source should be shorted and current source should be open. We are rewriting the circuit in a simplified form. Now RA is equal to, here these two resistors are in parallel, so we are writing in the parallel combinations formula, and these two resistors are in parallel, and RB is in the parallel form we are writing. We calculated the RA and RB, that is RA is 360 ohm and RB is 480.3687. So we are adding because they both are connected like this, so in series RA plus RB. RTH we get 480.6387 ohm. After this is the finalized Thevenin's simplified circuit network. After this we need to find the IAB. They asked to find the current across the galvanometer, because we writing VTH by RTH and we have a values of the both of, so we are substituting that and we got answer as 1.147119 into 10 power of 4 ampere. Thank you for watching. Please subscribe to my channel and press the bell icon for the further updates, and please like the video. Thank you.